Morning, everyone. We are actually going to start our probability unit today. And the first lesson that we're going to cover is what we call principles of inclusion and exclusion. And what I'd like you to highlight is that line right underneath. What numbers do we include and which do we exclude? Okay. The best way to look at this particular concept is to look at it through an example. So I'm going to give you a little silly example here. Let's take a look at it. Mrs. Staples has 28 students that are on the ND swim team. There are 12 students in Mrs. Turner's chemistry club. They decide to have a big bang splash bash over at Staples' house at the end of the year. So hold on, let's reiterate. Staples has 28 kids on the swim team. Turner has 12 kids in the chemistry club. They're going to have a big pool party at the end of the year. How many students can Mrs. Staples and Mrs. Turner expect at the party if 6 of the students are on the swim team and in the chemistry club? So let me give you it in a scenario. Miss Staples and Miss Turner sit down, they plan this idea, they think it's going to be great. Miss Staples devises her list of 28 kids on the swim team. Miss Turner puts her list together of 12 kids in the chemistry club, and they look at each other's lists and they say, hey, guess what? There's 6 people that are on the swim list that are also on the chem list. Okay, let's factor that in when we got to start thinking about, how many burgers are we going to order? So if 28 are on the swim team, 12 are on the chem club, and 6 are on both lists, how many kids are going to be at the party? Well, some of you will be able to, again, look at this question and very easily say to yourself, 28 on the swim, 12 on Turner's chem, that's 40 if they were all unique people, unique meaning different, but 6 of them are what we call the overlap. 6 of them are on Staples' list and on Turner's list. So that means at most they could expect 34 students at their party. This is a beautiful example of inclusion, including Staples, including Turner's, and excluding anybody that was double counted. Because if they wouldn't have compared lists, they would have said that they would have had 40 people at the party. Yet unbeknownst to them, 6 people, the 6 same people were on Staples' list and on Turner's list. So really, in terms of students, the max number would be 34. Now, some of these questions are easy, like this one, and you can mentally put the numbers together and figure it out. A lot of them are not that easy. So let me just show you how we could attack this in more of a mathematical way, and that mathematical way is what we call a Venn diagram. You've done Venns way back, guys. Grade 6, grade 7, my kids have done Venns, okay? So let me show you. We're going to create a circle. We're going to call it the Staples circle. We're actually going to call it set S for Staples. Then we're going to create another circle and we're going to overlap it over the set S and we're going to call it set T. The reason why we're overlapping it is because there actually was overlap on the lists. After I do that, I'm going to put both of my set S and my set T in a beautiful rectangle to tell the reader that I know this is everybody that I'm looking at. This is the group of people that I'm looking at. Okay. So NS is the number of people in set S on Staples' swim team. And we know that that's 28. And T is the number of people in set T in Turner's Chem Club. And we know that's 12. Now, what about this part right here? We call it the overlap. That's the number of people on Staples' swim and Turner's Chem. Now, the notation for that, watch me very clearly now, is N bracket S upside down U. It's a U upside down T. So hold on, let me get another highlighter out and let's highlight a few things. NS, NT, and NS and T. This is the and. Let's put that in pink. This is the overlap. This is the intersection. This is where the names were on both Staples and Turner's list. Okay, let's put some numbers to our diagram. Okay? Actually, sorry, we knew that this was 6 people. So I'm always going to start at the point of intersection. And I'm going to put that 6. Now I'm going to take my hand and I'm just going to disclose the Staples set. How many people did we say were on Staples' list? 28. But 6 are already included in the diagram for Staples. So that means how many are going to be over here if my total in Staples' circle has to add up to 28? Let's think about who these people are. 28 in total on her list. 6 of the 28 are swimmers, but also chemers. 22 of the 28 are just swimmers. They have nothing to do with chemistry. Okay, hold on. Let's just disclose the chemistry, Turner's circle, Turner's set. We knew that there were 12 people on Miss Turner's list. 6 of them are already included in her circle. So how many are going to be in this region to get a total of 12? Let's think about who these people are. 6 people are swimmers and chemers. 6 people are just chemistry club kids. They have nothing to do with swimming. Okay, hold on. I want to show you something cool. Go back over here for a second and remember the number of people coming to our party. 34. Now I want to show you something. 22 plus 6 is 28. Plus another 6 is 34. 34, Venn diagram also produces 34. Totally cool. This is known as set notation. Now, I want to give you a couple hints for when you're doing these questions, because every one of your homework questions will refer back to a Venn diagram. Hint number 1. Always start a Venn at the intersection, aka the overlap. So we always start our Venn right at that intersection point, that overlap point. Okay, number 2. Then figure out the remaining numbers in each set. So we started with the 6. We then figured out the 22. We started with the 6. We then figured out the remaining 6. That is our strategy for Venn diagrams. Okay. Now, let's take a look at part B. Determine how many students will be at the party, assuming, of course, that it's not to be missed at all. Well, here's what I want to tell you about these types of questions. There are 2 ways of answering this question. There's what we call the visual technique. And the visual technique is when you add the numbers in the circles. So if I add the numbers in the circle, 22 plus 6 plus 6 gives me my 34. The other way is using a formula. And if we look at the box, we have our first beautiful formula of the unit. So hold on, let's go through it just slowly, and then we're going to go through it with our call letters of S and T. So hold on, I haven't seen this symbol. N, A, or B. The total number of set A together with the total number of set B. This is the union of the 2 sets. So hold on, if I'm creating a union of Staples and Turner, it's going to be called N, S, or T. This is the union of the Staples set with the Turner set. The union of the 2 sets are being brought together at the party. Okay. NA is the total number in set A. In our case, the total number in Staples. NB, in our case, would be the total number in set T. So the union is of Staples or Turners. We add all of Staples. We add all of Turners. And then we subtract, hold on, the number in both set A and B, the intersection. So in our case, the intersection is S and T, and that was 6 people. All of Staples, all of Turners, minus the overlap. 28 and 12 is 40, minus 6 is 34. Notice again, two different ways of getting the exact answer. Now, sometimes visual technique is going to be your best method. Sometimes formula technique is going to be your best method. So visual technique was adding the numbers in the circle, gave us our beautiful 34. Formula technique was taking all of the original numbers, the 28 staples, the 12 turners, and the 6 overlap, and getting our beautiful 34. This is called principles of inclusion and exclusion. Really, really neat. Let's take a look and let's flip. Okay? What do we got here? A survey of 12 grade 12 academic math courses being taken was conducted at Notre Dame. Here are the results from 362 students being surveyed. So hold on, this little tidbit of information right there, that's telling me my N. That's telling me the total number of grade 12s at ND in that particular year. Okay, let's take a look. 182 were taking calculus. 162 were taking data. And at that time, we had a math class that was like an algebra class, and we had 102 of them taking that course. Okay. 45 said they were taking calc and data management. 68 said they were taking calc and discrete. 53 said they were taking data and discrete. And 22 said they were taking all three math classes. They were taking calc, they were taking data, and they were taking discrete. So this is a little bit different than the previous example, because if you take a look at the previous example, there were only two sets, Staples and Turner. In this particular example, there are three sets. There's calc, there's data management, and then there's discrete. So we're actually going to have three circles in this picture. Okay, so can everybody, when they draw this, please make the circles, a reasonable size, okay? So that your numbers are not too small. I'm going to call this set C for my calculus. I'm going to call this set DM for my data management. And I'm going to call this set D for my discrete. So notice how I've overlapped all three circles because there were 22 people taking all three of these courses. After I draw my circles, I'm always going to put a box around the circles. If you do not put a box, you will be losing 1 mark for every question bad form. The box is mandatory. Okay, let me be clear about that. Drawing this box is absolutely mandatory for every question. Okay? All right, so let me look back at my hints for a second. My hints say to always start in the intersection or the overlap. Well, my intersection and overlap, I've got a variety of places, but the very, very, very center of the picture is this cute little shape right in here. And if we were together, I'd be saying to you, okay, who can tell me what that little shape represents out of this list up here? And my hope would be that somebody would raise their hand and say to me, Miss Martel, that's representing the kids that are taking all three math classes. That's representing the 22 kids. They're taking calc, they're in part of the calculus circle. they're taking discrete, they're part of the discrete circle, and they're taking data, they're part of the data circle. Okay, let's tick that off. Now, let's look at the next piece of information. Data management and discrete. Data management and discrete. That's that elliptical shape right there. Data management and discrete. Well, that's supposed to be 53 people. But in that little hot pink shape, I've already got 22 included. So the number that's going to go over here is going to have to add up with the 22 to give me 53. So hold on, let's scoot over here for a second. 53 minus 22 is 31. 31 and 22 gives me 53, and that's my data management and discrete, kids. Okay, let's keep going. Calculus and discrete. Calculus and discrete. Calculus and discrete should be 68. But I've got 22 accounted for already in that elliptical shape. 68 minus 22 is 46. So 46 and 22 is giving me the total of 68. Just like 31 and 22 gave me the total of 53. Calculus and data. Calculus and data should add up to 45, but I've already got 22 in that circle. 45 minus 22 is 23. 23 and 22 adds up to the beautiful 45 of that elliptical shape. Okay, now let's take a look at the discrete circle. Let's take a look at the discrete circle. According to the discrete circle, I should have a total of 102 in that set. But I've got 46 already accounted for. I've got 22 already accounted for in the discrete circle. And I've got 31 already accounted for in the discrete circle. So 102 minus 46 minus 22 minus 31. I'm down to 3 people. Now, hold on. Let's talk about who these people are in this particular circle. 22 of them are taking all 3 math courses. 46 of them are taking 2 math courses, calc and discrete. 31 are taking 2 math courses, but data management and discrete. And 3 of them are only taking 1 singular math class, discrete math. That's who these people are. Okay. Let's look at my data circle. According to my data information, I should have 162 people in that circle. But I've already got 23 accounted for. I've already got 22 accounted for. And I've already got 31 accounted for. So 162 minus 23 minus 22 minus 31. That means that I have 86 people who are just taking data. 22 taking all 3, 31 taking discrete and data, 23 taking calc and data, 86 taking one math course, and the one math course is data. Okay. Calculus. According to my information, I should have 182 in this circle. Well, I've already got 46 accounted for. I've already got 22 accounted for, and I've already got 23 accounted for in the calculus circle, if I'm just looking in the calculus circle. So 182 minus 46 minus 22 minus 23, 91 people are just taking calculus. So hold on, 22 are taking all three, calc, data, and discrete. 46 are taking calc and discrete. 23 are taking calc and data, so 3 math courses, 2 math courses, 2 math courses. And 91 are taking just calculus. Beautiful 3-set diagram. Now, I want to talk about this particular question, and I want us to take a moment for a second and look back at the fact that we had 362 grade 12s surveyed. So can we take a moment here, and will you get your calculators out? And will you please add 91 to 46 to 3 to 23 to 22 to 31 to 86. Please do that right now, okay? It's very important that you see this yourself. So I took all the numbers in the circles. 91, 46, 3, 23, 22, 31, 36, and I think it should add up to 362 because that's how many we surveyed. Are you getting this number? Yeah, it's not wrong. It's not wrong at all. But we got a problem. If I'm telling you that it's not wrong, but the question is telling you that we surveyed 362 students, then what the heck? Where are those other 60 students? Where are they? Where did they go? Who are they? Maybe is a better question. Think of some of your friends here at Notre Dame. There's often kids that are graduates of the school that I don't ever really meet. Why? Because they don't take a senior math class. So who are these 60 people that are included in the rectangle? They're included in the entire set. They're included, but they're not in the circles. Who are these 60 people? Very, very key piece of information that, yes, they're included in the survey because they're a grade 12 student, but they're not taking any of my math classes. They are your grade 12 students that, yes, are part of Notre Dame. Oops, sorry, that should be a sad face. They're part of Notre Dame, yes, but they're not taking any math. So now, when I add up all the numbers in the circle, plus the 60 not taking math, now I get my true end value. Really, 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 really key piece that you cannot forget. You always, at the end of doing your circles, filling in all your numbers, you always have to do a double check and make sure that the numbers in the rectangle and the circle coincide with the total number that you're supposed to have. Okay? We didn't do that in example 2 because they never told us how many people were coming to the party. That was for us to figure out. So the 34 and the 34 totally jived. We didn't have to do that. This is a bit of a harder question. Okay. So beautiful diagrams, circles, extremely, neatly labeled, nice rectangle. Everything's complete. Now let's answer our questions. How many kids are taking only data? How many kids are taking only data? Just data alone? $86. Just data. They're in the data circle and they're not overlapped with anything else. Okay. How many students are taking a grade 12 math? Keyword is that "a." That "a" doesn't mean one math course. It would have to be worded, how many students are only taking one math course? That would be 91, 3, and 86. The word "a" means one course or two courses or three courses. That's the or. That's the or situation. That's the or. That's the union situation. Okay, well, we've got two ways of doing this question. Visual technique. Add numbers in circles. I've already done that. 91, 46, 3, 23, 22, 31, and 86. That's how many people are taking a math class. Some of them are taking 3 math classes, but they're taking math. Some of them are taking 2 math classes, but they're taking math. And some of them are only taking 1 math class, but they're enrolled in math. Formula technique is obviously going to be a little bit more complicated. Look at that thing. Because there's 3 sets. So let's mirror the formula. Let's mirror the formula with our call letters. Okay? So instead of A, B, and C, we're going to mirror the formula with calculus or discrete or data management. So instead of ABC, I'm going to use our set. Calculus, data, or data management. Okay, so let's take a look at what we do with principle of inclusion and exclusion. We include, and include. So I'm going to include all the calculus kids, all the discrete kids, and all the data management kids. Now, when you're using the formula, guys, you're assuming that you do not have this picture, okay? When you're using the formula, you use the information that was given to you right up here. You don't use the diagram when you're using the formula. They're 2 different techniques. So all the kids taking calculus is 182. All the kids taking discrete is 102. All the kids taking data is 162. I'm not looking at the picture at all. I'm using the information that was given to me. 182, 102, and 162. Now, hold on. Take a brief moment and just take your calculator and add those three numbers. I'm going to do it with you too. Look at what you're getting. 446. You've overcounted. People are being double counted in those numbers. We only have 362 grads. So if I'm getting 446, I've overcounted. Okay, so now it's time to exclude. So hold on, look, I've got exclusion, exclusion, exclusion. Okay, so I'm going to exclude the kids taking calc and data. I'm going to exclude the kids taking calc and discrete. And I'm going to exclude the kids taking data and discrete. Notice the and symbol, the upside down U. Again, I do not look at my picture. I'm not looking at this picture. I'm going right back up to my given information. Calculus and discrete. Calculus and data. Calculus and discrete. Data management and discrete. I've included and I've excluded. Now, hold on. Let's see if that's rectified things. We know we're looking for a magical number of 302. So hold on. 182 plus 102 plus 162. That was my 446. That was all of my inclusion. Now I'm going to subtract 45. Now I'm going to subtract 68. And now I'm going to subtract 53. We got a problem. 280 does not jive with 302. So we included, had too many. We excluded, and now we've subtracted too many away. We've over-subtracted. So wait a minute, what piece of information didn't I use? Well, I used the 182, I used the 162, I used the 102, I used the 45, I used the 68, and I used the 53. I didn't use the 22. Oh, are we supposed to include again? Yes, we're going to include. What happened is we pulled out the kids taking data, discrete, and calc. We over-excluded them. We pulled out those kids taking the 3 math classes. We over-excluded them. Hold on, let's try this one more time. Everybody with your calc. 182, 102, 162. Way too many. Minus 45, minus 68, minus 53. Too little. We've subtracted too much. Plus 22. Bingo, bongo. There we go. Formula technique, visual technique, absolutely the same answers. Beautiful technique. Okay, when you're ready, let's flip. I hope everybody can see this. Okay, let's flip. At the top of this next sheet, what you're seeing is basically the formula for 2 sets of data and 3 sets of data. And what I want you to understand is that these formulas represent the union of sets, and these formulas represent the OR. What you end up excluding is the overlap, the intersection, and the and. Again, these beautiful words of or, and and. And they have a huge amount of meaning in this particular unit. So overlap, intersection, and they all have the same meaning. Union and or all have the same meaning. Okay, I think we need to do a few more small examples just so that you've got the hang of it before you start the homework, okay? Suppose that we have 30 people in your math class and 10 people on your soccer team. You're having a party and you'd like to invite both groups. Sounds good. If no one on your soccer team is in your math class, how many people are at your party? No one on soccer is in math. Well, if that's the case, then I'm going to have set math and set soccer, but I'm not going to overlap them. I'm going to have 30 in math and 10 in soccer, always putting a rectangle. And my visual is going to tell me that I have 40 people coming to the party. My formula, if I want to include math or soccer, is going to be to take the total math kids, add them to the total soccer kids, and there's no overlap because there's nobody that's on both lists. Now, this has a special name. Okay, so do me a favor, scoot over to the left here. If two sets do not overlap or intersect, they are called disjointed. So these two sets are called disjointed sets because there's no overlap in that particular example. Okay, haven't seen that yet, but that's kind of cool. Let's take a look at part B. What if 3 people are in your math class and are also on your soccer team? Okay, so now, different scenario. You've got some overlap. This is the Turner-Staples scenario. So I'm going to draw 2 circles again, but this time I'm going to overlap them. I'm going to make them intersect because I've got 3 people that are on both. Okay, take it slow. How many people were in the math class? 30, but 3 are already accounted. That means 27. 27 and 3 give me my 30 for that circle. How many people were on the soccer team? 10, but 3 already accounted for. So that means 7. 3 and 7 give me my 10 for that particular circle. How many people will be at your party? So visual technique, 27 plus 3 plus 7. 37 people at the party. Formula technique. If I'm looking at the set of math or soccer, I'm going to take all the math kids. Remember, I'm not looking at the circle. All the math kids, all the soccer kids, that's 40. And I'm going to subtract the overlap of math and soccer. Take note of the or and the and symbols, right? Or is the regular U, And is the upside down U, and that was 3 people. 30 plus 10 minus 3, 37. So this example is basically the Staples and the Turner example. Visual technique, formula technique. Always remembering when I use formula technique, I'm not looking at the visual. I'm using the given information. 30, 10, and 3. That was not in the visual. That was all given to me in the wording of the question. Okay, let's keep going. How many cards in a full deck are face cards or hearts? Face cards or hearts? Well, let me think about this now for a second. Face cards, I've got 12. How am I getting that? Jack, queens, or kings. So, Jack of hearts, queen of hearts, king of hearts. Jack of diamonds, queen of diamonds, king of diamonds. Jack of spades, queen of spades, king of spades. Jack of clubs, queen of clubs, king of clubs. Hearts, I have 13. 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts, 6 of hearts, 7 of hearts, 8 of hearts, 9 of hearts, 10 of hearts, Jack of hearts, queen of hearts, king of hearts, ace of hearts. Okay, so hold on. Let's think about this visually. Do I have overlap? I certainly do. I've got a Jack of heart, a queen of heart, and a king of heart. 2 circles. I'm going to call one the face circle and one the heart circle. How much overlap do I have? Well, I've got 3 cards that are overlap. Jack of hearts, queen of hearts, and king of hearts. According to face cards, I should have 12, but 3 are already accounted for. According to hearts, I should have 13, but 3 are already accounted for. So how many, according to visual technique, are face cards or hearts? 9 plus 3 plus 10. 22. 9 just face cards. 9 that are face cards and also hearts, and 10 that are just hearts but not face cards. Okay. Formula technique says how many face cards or hearts? Well, I'm going to add all of the face cards, that was 12, to all of the hearts, that was 13, that gives me 25. But I have 3 cards that are face and hearts. 12 face cards, 13 hearts, but there's some overlap. There's 3 face cards that are also hearts, 22. This is also the Staples and Turner. Little bit harder than Staples and Turner because my expectation was that you know how many cards are face cards and how many cards are hearts, right? So you had to know that on your own. Okay, let's keep going. "24 students have a headache, 17 have a cold, and 11 have both." So that means 11 have a headache and a cold. That's your overlap. That's your overlap. Okay. Headache, cold, rectangle, start in the middle. How many kids supposedly had a headache? 24, but 11 were accounted for, leaving 13. How many kids supposedly had a cold? 17, 11 accounted for, 6 left over. How many students are there all together? Well, I don't have any other given information. So 13 had just a headache. 11 have a headache and a cold. And 6 have just a cold. 30 kids all together. Okay, do me a favor, take a look at 4. Just do a little read over yourself for a second. Out of 20 students, 12 take data, and 5 take both data and functions. How many just take functions? Okay, so hold on. Out of 20 students, that's my total. A little bit different than the previous example. The previous example was asking for the total. Okay. 12 take data, and 5 take both data and functions. Okay, a little bit harder, but you know what? I know that there's a data, and I know that there's a function circle, and I know that there's overlap. How many were the overlap? Okay, use that piece of information. How many took data? 12, but 5 are already accounted for. Okay. Now, how many were there in total? So in total, these circles should add up to 20. 12 or 7 plus 5 plus something gives me 20. 7 plus 5 plus something gives me 20. What's that something? 8. And let's take a look. How many kids just took functions? 8 kids just took functions. So these are going to take a little bit of practice, guys. I know this has been a long note. And some of the homework questions are going to be super easy. Some of them are going to be hard. Okay, I'm going to tell you right now. Make sure to do 14, 15, and 16. I've included full solutions, but they are more challenging and they need you to take a special look at them. Okay, so please do not skip over. Thank you.